All right, lesson 32. We're going to interpret and evaluate numerical expressions, including the language of scaling and fraction division. So let's take a look here at number 1. Circle the expression equivalent to the difference between 7 and 4 divided by a fifth. So we want the difference between 7 and 4 divided by a fifth. So we know we're going to take the difference, which is the minuend and the subtrahend in our subtraction. So we're going to take 7 minus 4 first and then divide that by 1/5. The only one that does that, we know that PEMDAS tells us that we're going to do the order operations. We're going to do whatever's in the parentheses first, then we're going to do exponents, then we're going to do multiplication and division as they appear from left to right, then we're going to do addition and subtraction as they appear left to right. So this is out of it because it has the 4 divided by 1/5 being done first. We know that we are this one, it can't be this because this is 7 minus 4 divided by 5. That can't be it. We want to divide it by a fifth. And this is a fifth divided by the difference between 7 and 4. So we know that this has to be our answer. And we don't have to solve it. It just wants us to circle it. But we know that this is saying we have to find the difference first, which would be 3 divided by 1/5. All right, let's take a look at this one. We're going to, for number 2, circle the expression equivalent to 42 divided by the sum of 2/3 and 3/4. So we're going to divide 42 by the sum. So first we have to find the sum of, we have to find the sum, and when we say sum, we know that this is addition. So, excuse me, this would be out of it because this is saying the sum of 2/3 and 3/4 divided by 42. So we know that that can't be it. This is saying 42 divided by 3/4 plus, excuse me, 42 divided by 2/3 plus 3/4. So that's not correct. We're looking for 42 divided by, so it's going to be 42 divided by the sum of these two numbers. We know we have to do these two numbers first, or in this case, it would be, this would be correct, as well as this, because this is saying 42 divided by the sum of 2/3 and 3/4. So both of these expressions would check out. All right, let's take a look at number 3 here. So number 3 says fill in the chart by writing the equivalent numerical expression or expression in word form. So we're going to be doing one or two things. In A, they're asking us for the numerical expression. B, they're asking us for the expression in word form. So we're going to change it up here. Let's read A. A fourth is much as the sum of 3 1/8 and 4 5/10. So we know that we're going to have to find this sum first. So this is going to be in parentheses. We know that we have 3 1/8 plus 4, and we can write it the same way they have it as a decimal. We could also change this to a fraction form of 4 1/2. So that's equal to 4 1/2. You can do it either way. Since you're adding a fraction plus a fraction, I would probably use that, but we can keep it this way since we don't have to actually solve our expression. Now, we said that we have a fourth as much, so it's going to be times 1/4. 1/4 as much, or 1/4 as much as the sum of these two numbers here. All right. Now we're going to rewrite or write the expression in word form. So this is saying we know that since this is addition, it's going to be the sum of these two numbers, and then we're dividing by 5. So we're just going to write that out. We know it's addition, so it's the sum of 3 1/8 plus 4 1/2, or 4 5/10 divided by 5. All right, so that's our answer for B. All right, now we said for C, it says multiply 3/5 by 5 and 8/10, then half of the product. So it's a couple ways we can write that. We can go ahead and write it out. I probably will write it this way first. 3/5. Go ahead and make those parentheses a little bit bigger. 3/5 times, it says multiply the two numbers. 3/5 times 5 and 8/10 divided by 2. Also, we could have wrote it as a fraction and had everything with our fraction bar over 2. Instead of having this here, we could have had it the fraction bar over 2. All right. And this is saying 1/6 times the difference between 4 and 8/10 and 1/2. So 1/6 times, another way to write that would be 1/6 as much as. So we can write that same way we have here. As much as is going to be our times. So we have 1/6 as much as, and a subtraction, so it's going to be the difference between, and then between what two numbers, our minuend, if we set it up in standard algorithm for subtraction, that would be the top number, and our subtrahend, which would be our 1/2. Now, of course, 1/2, we can write that as 1/2 is also equal to 5/10 if you wanted to use the decimal form. All right, last but not least, let's take a look at letter E here. And we have 8 minus, and then we have our parentheses, 1/2 divided by 9, close parentheses. And that was open parentheses, close parentheses. So it would be the difference between, because we're doing subtraction. So let's write that in first. And the difference between what? So it's 8 and, so now 8 and what? So 8 and, this is the answer between this division problem. So we're going to put 8 and the quotient of 1/2 and 9. So the quotient is the answer to a division problem, and we know we have our dividend and our divisor. So that's how we have to make sure we write our 1/2 first and then our 9 second, because the quotient between 1/2 divided by 9. All right. For number 3, it says compare the expressions in 3a and 3b. So we're comparing this and this. Well, the expressions, we're comparing these two right here. It says without evaluating, identify the expression that is greater and explain how you know. So if we're looking at these two, we know that in both cases, this is multiplying, saying you have whatever this, when you add your sum, when you take your sum of these two numbers, when you get your sum of these two numbers, you're going to multiply it by 1/4. And in this case, we're going to divide it by 5. So multiplying by 1/4, in this case, remember, if we were to take our inverse operation and make this into a multiplication problem, it would be times, and then the reciprocal of 5 wholes would be 1/5. So by looking at that, I know that this is going to be split into more parts here, so that means that this would be greater. If I have whatever you have here, you have there, so it's the same thing. So if I'm splitting something into fourths, it's going to be bigger pieces than if I split something into fifths. So A would be greater. So this one would be greater. And I know that because once I use my inverse operation and my reciprocal, I would have fourths here where I would have fifths here. Think about cutting a pizza into 4 pieces. That would be bigger. Each piece would be bigger than if I was to cut another pizza into 5 pieces. All right, let's move on. So evaluate the following expression. So we're going to evaluate. In this case, we have to do our follow the rules. P is for parentheses, exponents, multiplication and division, and we have addition and subtraction. Now remember, these are as they appear from left to right, only for those two. So if you have addition and subtraction in the same expression, you would do them as they appear from left to right. Same thing with multiplication and division. So this would be 1, 2, 3, 4. That's the order that you're doing them in. And of course, if you have a 1 and a 3, you would go 1 and then 3. If you have a 1, 3, and a 4, you would go 1, 3, 4, and so forth. So here we have a 1 parentheses and then a 3 for division. So we're going to do what's inside our parentheses first. 11 minus 6. I know that 11 minus 6 is 5. So now I have 5 divided by 1/6. Just like we've been doing, I'm going to take the inverse operation, multiply by 6, and I know that I would get 30. So 30 would be my answer here. Let's take a look at this one. First thing I'm going to do, what's in my parentheses? So I have 4 times 1 over 6, which equals 4/6. 4/6 is equal to 2/2, 2/3. Then I have 2/3 times 9/5. This is coming all the way down here, and this is coming there. I have 2 times 9, and I have 5 times 3, and that is equal to 18/15. I know that I can take 15/15 to get 1 whole, and then I'll have 16, 17, 18, 3/5 remaining, 3/15 remaining. So my answer would be 1 and 3/15. You don't have to simplify, we can stay there, but if you wanted to simplify, you say 1 and 3 divided by 3 is 1, and 15 divided by 3 is 5. 1 and 1/5. Excuse me. Next, I have a parenthesis, so I'm going to do what's inside my parentheses first, and I'm just going to do the inverse operation. Remember, we talked about if I'm dividing a whole number, if I have a whole number as my dividend, and I'm dividing it by a fraction, 5 divided by 1/2 is going to give me a whole number. So I know that this is going to be 10. 5 divided by 1/2 is 10. If you want to do the inverse operation, you could do that and say 5 times the reciprocal, turn that 1/2 upside down, and you get 2 wholes, and that's equal to 10. I know that this checks out. Now I'm going to do my division and say, well, 1/10 divided by 10 is the same thing as if I was to do my reciprocal, saying 1/10 times, well, 10, I'm going to turn into 1/10 because I'm just taking the reciprocal of 10 wholes, and that would be 1/10. And I know that this is going to be equal to 1/100th. All right, that'll be my answer for C. So now we have multiplication and multiplication. Remember, as they appear from right to left, I'm going to do this one first. I'm going to say 2 times 3 is 6, and 4 times 5 is 20. Then I'm going to bring this down and say 4/3. 4 times, or 6 times 4 is 24. If you had 3 20s, it would be 60. We can stop there, and that would be our answer. If you want to go ahead and simplify, you can. Say, well, I know that these both are divisible by 12. 12 goes into 24 2 times, or 24 divided by 12 is 2, and 60 divided by 12 is 5. And we know that that would be our answer there. Now we have 50 divided by the difference between 3/4 and 5/8. So let's take a look at that. We have 50 divided by the difference between 3/4 and 5/8. Let's take our time and get this right here. So we know we would have 50 divided by, we can use our fraction bar, and we have 3/4 minus 5/8. Another way, of course, we could have wrote it out was 50 divided by the difference between 3/4 and, oops, that's supposed to be subtraction, not division, and 5/8. All right, so either way will work. I'm going to show you this way first. Well, I know that 3/4, I can't take 5/8 away from 3/4, so I would have to have the same denominator. So what I'm going to do is say, well, I know that if I'm trying to get eighths, I would just multiply this by 2. And if I multiply my denominator by 2, I'm going to have to multiply my numerator by 2, because in essence, 3/4 times 1, remember this is fractional form of 1, is equal to 6/8. So 6/8 minus 5/8 is going to be 1/8. So this is equal to 50 over, or divided by, 1/8. And if we wanted to evaluate that or solve that, we could say 50 divided by 1/8 is equal to 50 times the inverse operation, multiplication, and the reciprocal times 8 wholes. So 50 times 8 wholes is equal to, well, I know 5 times 8 is 40, so 5 tens times 8 is going to be 40 tens, which would be 400. All right, let's pick up the pace here. Looking at this last problem, let's take a look at Lee. Lee is sending out 32 birthday invitations. She gives 5 invitations to her mom to give to family members. Lee mails a third of the rest. Okay, so she's mailing a third of the rest. And then she takes a break to walk her dog. So write a numerical expression to describe how many invitations Lee has already mailed out. So we want to see how many she mailed out. So we know that. Let's draw a tape diagram here to see. So we know that she wanted to send out a total of 32 invitations, right? So she had, let's split this into 4 parts. This is going to be represent the 5 that her mom mailed out. So this is what her mom gave to the family. These 3 boxes here are going to represent the, let me change the color here, going to represent the 32 minus the 5. So you had the whole 32, and this is the 32 minus the 5. So now this is 1/3 of 32 minus 5, and each of them will be the same. So that would be 1/3 of 32 minus 5. And lastly, 1/3 of 32 minus 5. So now this is what she mailed out. Oops, excuse me, not the whole thing. She just mailed out one of those. She mailed out this here, 1. So she mailed out 1/3 of the remaining. So we would say that she had 32 minus 5. Difference between that, the difference between 32 and 5 divided by 3. She split it into 3 groups. All right, It says, which expression matches how many invitations still need to be mailed out? So she already took away one of the thirds. So it would be 32 minus 5 minus a third of 32 minus 5. So she had the 32 minus 5, and then she subtracted another third. So she still has the 2/3. So this first one would be our best option. And if you looked at that, she would have those 2/3 of 32 minus 5 remaining. Hopefully this helps. As always, like and subscribe if you haven't done so already. If you got a family member or somebody who you think would benefit from some 5th grade math, please have them like and subscribe. Also, any questions that you have, feel free to leave in the comments section. And as always, feel free to ask questions in class tomorrow. Thank you so much.